In part one, we discussed previous methods that we use to solve quadratic equations. We discussed the discriminant and how it affects the quadratic functions. So it essentially tells us how many and what type of solutions we would have. Now, on the second part, we are going to be solving using the quadratic formula. The quadratic formula, which is listed on that front page, is negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember that part that's underneath the radical, the b squared minus 4ac, that is the discriminant. Let's start with example 2, part A. So 2a, the first thing that you should do is identify what A, B, and C would be. A is 1, B is 10, C is 2. Now that I have my A, B, and C, I can plug it into the quadratic formula. So we have x equals negative b, so that's negative 10, plus or minus the square root of b squared, so 10 squared, minus 4 times a, which was 1, times c, which was 2, all over 2 times a, which was 1. What I'm going to do now is I'm going to clean up the discriminant. So I have 10 squared, which is 100, minus 4 times 1 times 2, so that's 8. That leaves me with negative 10 plus or minus the square root of 92 all over 2. I'm not done yet. What we need to do now is see if we can simplify the radical. When we simplify radicals, remember we need to check and see if any of the factors are perfect squares. So when I think of 92 and its factors, the first thing that comes to mind for me is 4 times 23. 4 is the perfect square of 2, and then 23 has no factors that are perfect squares other than 1. So I know it would be simplified all the way if I use this. What this becomes is negative 10 plus or minus, like I said, the square root of 4 is 2, and that 23 needs to stay within the radical, all over 2. I'm not done yet. I need to see if I can simplify any further. So we've already simplified the radical, but now I want you to notice that we have 10 over 2 and 2 over 2. So if I break this apart, it's really negative 10 being divided by 2 and 2 root 23 over 2. So it looks like this. I'm going to scooch it over here real quick for you. So I really have negative 10 over 2 plus or minus 2 root 23 over 2. Negative 10 over 2, that's a negative 5, plus or minus. Now, I can only simplify the whole numbers. I cannot divide what's underneath the radical by the 2. So 2 over 2, that becomes 1. So I have 1 times the square root of 23, or just the square root of 23. So my answer is this, or I can list it out as two different solutions. I have a negative 5 plus the square root of 23, and I have a negative 5 minus the square root of 23. Scooch that over. Now I do want to point out that on the front page, for example 1a, we had x squared plus 10x plus 2, which is what we just solved using the quadratic formula. Now we did say that we would have two real solutions because the discriminant was positive. And notice I do have two real solutions. I have no imaginary numbers here. All right, 2b. First thing you need to do is identify A, which is 1, B, which is a -6, and C, which is a +9. We're keeping all of those signs. Plugging it into the quadratic formula, I have negative B, so a -6, plus or minus the square root of B squared, so -6 squared, minus 4 times A times C, so 1 times 9, all over 2A. Notice how I wrote my -6 inside of parentheses. That's going to help me see more clearly what's going on. So I have a -6. That becomes positive because 2 negatives makes a positive. So +6 plus or minus the square root of. I have -6 being squared, which gives me a +36. Minus 4 times 9, that's 36. So 36 minus 36 is 0, and that's all over 2. The square root of 0 is just 0. So really, this is 6 plus or minus 0 over 2. And whenever you add or subtract 0, that doesn't make any difference to this number right here. So really, I can go further and say I have 6 over 2. And 6 over 2 is just 3. So with my answer being 3, I have one real solution. And if we look back to, let's switch with this one. If we look back to 1b, you can see that when we found that the discriminant was 0, we did say we'd have one real solution. 2c, while I have it here, I'm just going to point it out, is the same thing as 1c, and we ended up with a discriminant of -15. Now notice how we said we're going to have two imaginary solutions, so let's see how that plays out here. A is 2, B is -1, C is 2. Plugging it into my quadratic formula, I have negative B plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. 2 negatives makes a positive, so I have +1 plus or minus the square root of, we already showed the solution process in 1c, so I know the discriminant is -15 because I had 1 minus 16, all over 2 times 2, which is 4. Now I need to simplify. So the first thing I'm going to do is simplify the radical. Notice how I have a negative root. When we were solving using complex numbers, we learned that I can break this apart as the square root of 15 times -1. The reason why I want to split that up is I could then write it as square root of 15 times the square root of -1, and I know that the square root of -1 is equivalent to I. So really, this is the square root of 15I all over 4. 15 has no perfect squares other than 1 because its factors are 1 and 15, 3 and 5. So it is simplified now that we've pulled out the I. When we have, this is a complex number because I have a real and imaginary portion, we like to write it as the real number first and then the imaginary number second. I do have it written in that form. However, you may want to go one step further and split it up. This is 1 divided by 4 and root 15I divided by 4. So that means I have 1/4 plus or minus root 15I over 4. So I do have, like we said, two imaginary solutions. The first one is 1/4 plus root 15 over 4I, and the second one is 1/4 minus root 15 over 4I. So we are now done. Example 2D, let's once again identify A, B, and C. Plug it into our equation, so I have negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. First thing I'm going to do is I'm going to clean up the discriminant. I have negative 7 plus or minus the square root of 7 squared is 49 minus 4 times 1 times 10, that's 40. So 49 minus 40 is 9 over 2. Notice how I have a positive discriminant, so I know that I'm going to have 2 real solutions. If you want to make a note, you can. We're going to have 2 real solutions, otherwise I'm going to keep going forward. So now I need to see if I can simplify this radical, and I can. 9 is a perfect square of 3, so I have negative 7 plus or minus 3 over 2. Now we always want to simplify all the way, and this is not the most simplified answer. What I really have here is 2 different things. The first thing that I have is negative 7 plus 3 over 2, and the second thing that I have is negative 7 minus 3 over 2. We are able to simplify further by combining like terms, because all of these are whole numbers. So I have a negative 4 over 2, which is negative 2. And I also have a negative 10 over 2, which is a negative 5. So I have 2 real solutions. All right, last one, 2E. I wanted to throw in a problem like this because some people would be confused saying, hey, that's not written in standard form. Well, you're right, it doesn't appear to be written in standard form, but we could rewrite it into standard form. We have an x squared term and a number, so what we're missing is an x term. And if I don't have anything written there, we could substitute in a 0. So I really have 2x squared plus 0x minus 19 equals 0. In this case, A is 2, B is 0, and C is a negative 19. Now that I've identified A, B, and C, I can plug it into my quadratic equation. So that's negative B, which is 0, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. Negative 0, well, that's just 0, plus or minus the square root. I have 0 squared, which is 0, so I'm just going to write it here. 0 minus 4 times 2 times 19, so minus a negative 152 or plus 152. And that's all over 4. Now we need to begin the process of simplifying since we've plugged everything in. I can simplify this radical here by rewriting it as, let's see, 152 is divisible by 4. That'd be 4 times 38. Yeah. Using product property, we can split this up. So the square root of 4 times the square root of 38. And that would become 0 plus or minus the square root of 4 is 2, square root of 38, all over 4. You could check and see if 38 simplifies any further, but it's not divisible by any perfect squares other than 1. So it is simplified at this point. What I'd like to do now is get rid of this 0. It's not important. Really, this is plus or minus 2 root 38 over 4. The 2 over 4 does simplify to 1/2, so that would leave me with plus or minus root 38 over 2.